Alright guys, our topic for today is bias in science experiments. Bias, you may have heard before, is kind of the same thing as the word prejudice. It basically means that you're not taking a fair view of the material, or you're not presenting the scientific experiment fairly. You're not giving the real accurate results. Bias in scientific experiments can come in two main forms. The first form is called sampling bias. Sampling bias occurs when my sample is not good enough. A sample is the group of individuals that I'm testing. A sample cannot be good enough if I don't have enough participants. Sampling bias occurs when the sample that I'm testing is not really an accurate reflection of the population. So, for instance, let's say I want to find out who's smarter, boys or girls. So I go to detention and I pick 5 girls. Then I'm going to go to tutoring group, after school tutoring, and I'm going to pick 5 boys. Those 5 boys are the ones who are doing the tutoring. These 5 girls were in detention because they got in trouble and they weren't paying attention in class. Who do you think is going to do better on the test, the boys or the girls? Does that mean that the boys are going to be the ones that are smarter? Does that mean all the time boys are going to be smarter? No, because of sampling bias. The group that I was testing on is not an accurate reflection of the population in the school. In order to get rid of sampling bias, we have to have what's called a random sample. This means that my participants in my experiment are chosen at random. A better way to do that experiment would be to go to the cafeteria. Every 3rd person through the line, I take over to a class and they take a test. That would give me a random sample and would get rid of sampling bias. Remember, bias is bad in science. I also would want to make sure that I have a lot of participants. 10 people taking a test is not enough to determine who's smarter, boys and girls. I would want to do hundreds, thousands, millions of people, because the more data that I have, the more accurate my results. Let's look at the other kind of bias. This is called measurement bias. And this happens when my measurements aren't very accurate. Let's say, for instance, I'm testing to see if a plant grows taller when it's in red light as opposed to white light. And I say, yep, the plant grew pretty tall. Well, tall compared to what? Tall compared to me? Tall compared to the little bean that it started out as? What would be a better way for me to give an accurate measurement instead of just comparing it to something? I could use what? Numbers. Giving a numerical measurement is a great way to get rid of measurement bias. And again, just like in the sampling bias, the more times I do my experiment, the more people I test on, the more likely I am to get rid of bias altogether. So, let's recap and make sure you put this in your lab journal. Good science depends on a well-designed experiment that makes sure that we have a big sample size, a random sample, and that I use good measurement techniques. That's all for now, guys.